In this video, I will show you how to sketch the region bounded by the graphs of the equations and find the area of the region. Looking at the negative x squared, I know this is some type of an upside down parabola. And I know that y equals negative x plus 1 is a line with a slope of negative 1. We need to find the points of intersection. Well, at least we need to know what the x values are. So let's set these two equations equal to each other and solve. So we start out with this. Adding x to both sides, we have negative x squared plus 4x. Subtracting 1 from both sides, the 1's cancel each other out, and we have equals 0. I don't like the leading coefficient to be negative, so I'm going to divide everything by negative 1. So I end up with x squared minus 4x is equal to 0. Factoring out a common factor of x, I get x times x minus 4 is equal to 0. Using the zero product property, I know that x equals 0 and x equals 4. So here is a sketch of the line y equals negative x plus 1. And here is a sketch of the parabola negative x squared plus 3x plus 1. I've drawn them so that they intersect at 0 and 4. When you are integrating with respect to x, you can find the area between two curves by integrating the top function minus the bottom function. So here's the top function minus the bottom function, but let's go ahead and distribute this negative sign. So we should get positive x minus 1. So let's clean this up a little bit by combining like terms. So we have the integral from 0 to 4 of negative x squared. 3x plus x is 4x. And then plus 1 and minus 1 cancel each other out. Let's go ahead and integrate term by term. So I'm going to increase this exponent by 1. And then divide by the new exponent. I still have this negative sign in front. And then moving on to the 4x term, I'm going to increase this exponent by 1. Now, dividing by the 2, this is 4 divided by 2, which is 2. So now we will evaluate using the limits of integration from 0 to 4. This means we need to find the value at 4 minus the value at 0. The value of the second part is 0, so this will be gone on the next step. Applying the exponents, we have this. Multiplying, we have this. Making like denominators, we have this. So the final answer is this. 32 over 3 is the area between the two curves. On a free response question, I recommend that you leave your answer in this form. You will get full credit without risking losing points in the simplification process. Problem number 36 is calculator active, so we will let our graphing calculator do most of the work. Hit y equals and type f of x into y1. Before we graph, let's adjust our window a little. The x values are between 0 and 3. So hit the window button and let's let x min be 0 and let's let x max be 3. Let's go ahead and hit graph and see what we have so far. The area that we need to find is also bounded by the line y equals 0, which is the x-axis. Let's actually include this as one of our equations. So I'm just going to put y equals 0 and graph again. So this is the graph. I'm going to take a picture of it. So here is the area that we need to calculate. If you integrate with respect to x, you can find the area between two curves by integrating the top function minus the bottom function. In this case, the bottom function is 0, so we didn't really need to write that. As we use the calculator, remember that we typed f of x into y1. We can type this into the calculator. So we're integrating from 0 to 3, and f of x will be y1. So hit second quit to get to a blank screen. To integrate, hit Math, and then choose option 9. We are integrating from 0 to 3. To access y1, hit the vars button and switch over to the vars menu. Hit enter for function and choose y1. And don't forget the dx. And that's it. 6.908 if you round up. On the AP exam, you can either round to the nearest 3 decimal places or you can truncate. So 6.908 or 6.907 would get full credit. Number 40 is also calculator active, so I will type f of x into y1 and g of x into y2. Notice that there is no secant button on the calculator, so I will have to write this part as 1 over cosine of pi x over 4. So I need 1 over cosine. So I will hit alpha y equals enter to set up the fraction. And now I can type cosine, and I need pi x. So second pi x. And this needs to be over 4. So I will hit alpha y equals enter again to make a fraction with a denominator of 4. Next to that, we can type tangent of pi x over 4. Let's type g of x into y2. So this is the square root of 2 minus 4 times x. And plus 4. Let's hit zoom 6 to get our first glimpse of what the graph looks like using a standard 10 by 10 window. Don't forget that x equals 0 is also a boundary. That's the y-axis. So keeping that in mind, it's this tiny little area right here between the y-axis and the blue curve and the red line. That is the area that we're trying to calculate. So I'd like to zoom in on this. I think I'm going to try zoom box, which is kind of fun. I'm going to move the cursor to the lower left-hand corner of the area of interest, and I'm going to hit enter. Now I'm going to move the pointer to the upper right-hand position of the area of interest. And as I move it, it draws a box showing what the zoom will be once I hit enter. So this captures the entire area that I care about. So hit enter. So this is a pretty good view. Let's take a picture of this. So this is the area that we need to find. To set up the integral, we need to know the x value of this intersection point. It seems to be 1, but let's not assume. So hit second trace and choose intersect. Move the pointer very close to the point of intersection and hit enter for first curve, hit enter again for second curve, and just hit enter a third time for guess. And we see that the intersection is at x equals 1. When we integrate with respect to x, we can find the area between two curves by integrating the top curve minus the bottom curve. I had the colors of my boxes mixed up for a second there, but the top curve is the linear function, which is g of x. The bottom curve is this trigonometric function, which is f of x. So we will integrate from 0 to 1 g of x minus f of x. Remember, when I go to the calculator, this will be y2 minus y1. So let's do that now. Let's quit our way out, and to integrate we will hit Math and choose option 9. We are integrating from 0 to 1, and we need y2 minus y1. To access y2, we will hit the vars button, switch over to the yvars menu, hit enter for function, and choose y2. And then we can do minus and repeat for y1. Hit vars, yvars, enter, y1. So this is y2 minus y1, and all we need is the dx. And that's it. So the area is 2.179 if you truncate, or 2.180 if you round. So that's it for number 40. Set up and evaluate the definite integral that gives the area of the region bounded by the graph of the function and the tangent line to the graph at the given point. Let's start by finding the equation of the tangent line. We know that we will need a point and the slope, but they gave us the point -1, 1 as the point of tangency. So all we really need to do is to find the slope. We can use the derivative in order to find the slope. So y prime is equal to 3x squared minus 2. So let's evaluate y prime at x equals -1, the x coordinate of the point of tangency. So that will be 3 times -1 squared minus 2. So that is going to give us the slope. Well, this is really just 3 minus 2, which is 1. So the slope is 1. So the equation of the tangent line is y minus y, so y minus 1 is equal to the slope times x minus x. Well, x minus -1 is x plus 1. We will be using our calculator since this is a calculator active problem, so let's get y by itself for easy graphing. Adding 1 to both sides, I get y is equal to x plus 2. So this is the equation of the tangent line, which I will type into y2 on the calculator. Let's type the cubic function into y1. So here we have it. Let's hit zoom 6 to get a glimpse of what we have so far. We need to find the area bounded by the tangent line and the curve itself. So I am going to zoom in on the area of interest by using zoom box. So I hit zoom, and option number 1 is zoom box. I'm going to move the pointer to the lower left hand corner of what I'm interested in, and I hit enter, and then I move the pointer to the upper right hand corner of what I want to see, and I hit enter. We need to find the intersection points. Actually, the first intersection point is the point of tangency that we were given. So we know this is -1, 1. So it's really just the intersection point on the right that we need to find. So hit second, trace, and intersect is 5. Move the pointer very close to the intersection of the two curves, and hit enter. And hit enter again, and when it says guess, just hit enter again. So this intersection is at the point 2, 4. Let's take a picture of this. If we integrate with respect to x, we can find the area between these two curves by integrating the top curve minus the bottom curve. So we will integrate from -1 to 2. The top curve is the tangent line. So that's going to be x plus 2. And then minus the bottom curve, which is the cubic function. So we could type all of this into our calculator. However, don't forget that we typed the x plus 2 into y2, and we typed the x to the third power minus 2x into y1. So we can just integrate y2 minus y1. So let's quit our way out of this and hit the math button, choose option 9 for integration, and we are integrating from -1 to 2. And for y2 minus y1, hit vars, switch over to the yvars menu, hit enter for function, and choose y2. And then minus, and then back to the vars, yvars, enter, and then y1. And just put x. So the area is 6.75. So that's it for number 62. For number 72, we need to find A such that the line x equals A divides the region bounded by the graphs of the equations into two regions of equal area. No calculator. Notice that x equals 0 is the y-axis. The y squared means that we're talking about a parabola. The fact that y is squared and not x squared means that it is a sideways parabola. The fact that the x term is negative tells me that this is a sideways parabola that is facing towards the left. We can find the x-intercept of the sideways parabola by plugging in 0 for y. So that gives us 0 is equal to 4 minus x. Adding x to both sides, we get x is equal to 4. This is the x-intercept. We can find the y-intercept by plugging 0 in for x. So that gives us y squared is equal to 4. Taking the square root of both sides, we get y is equal to plus or minus 2. So these are the two y-intercepts. So here is a sketch of the sideways parabola. And here is the area bounded by the y-axis and the parabola. We need to find A such that the vertical line x equals A separates this area into two regions of equal area. We can simplify the problem considerably by only looking at the top half of the picture. If we find the vertical line x equals A that cuts the top half into two equal areas, that same line will automatically cut the bottom half into two equal areas as well. Let's create an integral that will give us the area on the left and set it equal to an integral that will give us the area on the right. Since I will be integrating with respect to x, I need to write this parabola as a function of x. So I need to get y completely by itself. Let's take the square root of both sides of this equation, which will give me y is equal to plus or minus the square root of 4 minus x. Now, the plus part is the top half of the parabola. The minus part is the bottom half of the parabola, which I just erased. We just need the top half of the parabola, so y equals the square root of 4 minus x. Normally, when we find the area between two curves, we integrate the top function minus the bottom function. But since we are just using the x-axis, we don't have to do a top function and a bottom function. We can just find the area between the parabola and the x-axis by integrating the square root of 4 minus x. For the area on the left, we need to integrate from 0 to a. We don't know what a is yet, but it's some constant. So the integral from 0 to a of the square root of 4 minus x dx. For the area on the right, we will integrate from a to 4. And this will still be the square root of 4 minus x. So let's just calculate both of these integrals and solve for a. The square root of 4 minus x is the same thing as 4 minus x to the 1/2 power. I am about to do a mental u substitution in order to find the antiderivative of this expression. So if I let u be 4 minus x, u prime will simply be negative 1. That means the only thing I need to do to compensate for the substitution is that I'm going to need a negative out in the front. So let's keep the u, the 4 minus x, and add 1 to the exponent. So adding 1 to 1/2 gives us 3/2. Then we divide by the new exponent. Dividing by 3 over 2 is the same thing as multiplying by 2 over 3. So we will have to evaluate this from 0 to a, the limits of integration. Doing the same thing on the right, we will get the exact same expression, negative 2/3 times 4 minus x to the 3/2 power. But this time, we will be evaluating from a to 4. So back to the left-hand side of the equation. I am going to leave the negative 2/3 out in the very front. And evaluating from 0 to a means I need to find the value at a minus the value at 0. So this will be 4 minus a to the 3/2 power minus 4 minus 0 to the 3/2 power. And now on the right-hand side, again, I will leave the negative 2/3 out in the front. This time I need to find the value at 4 minus the value at a. So the value at 4 is 4 minus 4 to the 3/2 power. And then the value at a is 4 minus a to the 3/2 power. I'm noticing that we have negative 2/3 on both sides of the equation. So if I divide both sides by negative 2/3, that is going to be gone. Also, I'm noticing that we have 4 minus 4, which is 0, to the 3/2 power. So on the next step, this will also be gone. So now we have this. Let's add 4 minus a to the 3/2 power to both sides of the equation. I'm noticing that we have another 4 minus a to the 3/2 power on the left. So if I add this to the left-hand side, I'm going to have 2 of these. Also, on this step, I'm going to emphasize the fact that the 3/2 power is the third power and the square root. When you have a fractional power, the numbers are in the form power over root. So the 2 means it's the square root, and the 3 means it's the third power. So now we have this. The square root of 4 is 2, and 2 to the third power is 8. If we add 8 to both sides and divide by 2, we get 4 minus a to the 3/2 power is equal to 4. We can get rid of this fractional power by doing the reciprocal power to both sides of the equation. So I'm going to raise both sides of the equation to the 2/3 power. The 3/2 and the 2/3 cancel each other out. So on the left-hand side, I just have 4 minus a. And on the right-hand side, I have 4 to the 2/3 power. To get a by itself, I'm going to add a to both sides and subtract 4 to the 2/3 power from both sides. So that will leave me with 4 minus 4 to the 2/3 power is equal to A. And this is the answer. This is the value of A that separates the left side and the right side into regions of equal area.